Industrial combustion has been associated with localized high volume and high concentration sources of CO2 emissions. This is especially true for industries characterized by high energy consumption, such as pulp and paper, chemical, gas and petroleum, steel, mining and mineral processing industries. In addition, the high exhaust temperatures of stacked gases generated by these industries adds even more heat to the atmosphere. But now a relatively obscure technology is being used to dramatically reduce these emissions and offer operators substantial savings in energy and fuel costs, further contributing to the responsible use of combustion in industry. Submerged combustion. The principle of submerged combustion is simple. Take a glass of water and a straw, insert the straw into the water, blow air into the straw and watch the bubbles rise to the surface. Now imagine that the bubbles are very hot. As they rise to the surface, they heat the water in the glass. Conventional methods are wasteful. Consider the simple example of heating a pot of water on a stove. Much of the energy required to heat the water is also used to heat the pot, and a lot of energy simply goes into the atmosphere and never recovered. Of course, industry uses more sophisticated systems, steam boilers and immersion tube heaters, but these systems are expensive to operate and maintain, and the majority of commercial and industrial heating appliances operate with energy losses up to 30% and spew out hot greenhouse gas emitting stacked temperatures between 350 and 700 degrees Fahrenheit. Conversely, SubCom's patented systems provide efficiencies of 90 to 100% and stack exhaust temperatures close to ambient atmospheric temperatures. Translation: a 30% reduction in fuel and energy costs and negligible gas and particulate emissions. Of course, submerged combustion is more complex than simply blowing hot air through a straw. A fuel-air mixture is ignited in a cylindrical chamber, which is submerged in a liquid solution or slurry. Positive pressure evacuates the chamber of liquid, thereby allowing adequate liquid-free volume for essentially complete combustion before the hot exhaust gases contact the liquid. When the gases reach the end of the cylinder, they form tiny bubbles that are in intimate contact with the liquid medium. Upon contact with the liquid, sensible heat transfer from the gas bubbles causes a rapid drop in gas temperature and an increase in liquid temperature. At the same time, the exhaust gas becomes saturated in vapor. As the bubbles move toward the surface of the liquid, the hot saturated vapors continue to transfer latent heat to the liquid. At the surface of a unit, the temperature of the liquid and the saturated exhaust gas are within 10 degrees Fahrenheit. SubCom systems are now being used for a variety of industrial solution heating problems, and it has proven to be particularly valuable where solutions are aggressive, dirty, or corrosive, situations where conventional methods are simply not appropriate. SubCom systems are used in a number of mining applications, such as heat leaching operations in copper mines, raising the temperature of raffinate, a mild solution of sulfuric acid, to increase its leaching capability. Also in mine decommissioning processes, and for potash, gold, and iron ore slurry heating systems. In the lumber industry, SubCom is used in plywood and veneer plants for log ponds and conditioning chests. Treating wastewater sludge is a big challenge, and municipalities throughout the world are struggling to maintain aging systems that are inefficient and breaking down. SubCom is used in sludge pasteurization processes to destroy pathogenic bacteria present in the sludge. This is a new application that has garnered favor because of environmental compliance requirements. Any industrial process that requires solution evaporation or the heating of large amounts of contaminated or corrosive water can take advantage of the efficiencies and environmentally sound processes provided by SubCom systems. Submerged combustion is a simple application for a complex problem. How do you meet energy consumption demands of industry and yet use natural energy resources more responsibly? while reducing particulate and greenhouse gas emissions that threaten the very air we breathe and the water we need to sustain life? Well, it's complex. We believe that submerged combustion is a big step in the right direction. To find out more, please request information right here or contact us directly through the contact information provided. And thank you for your valuable time.